Okay, so first of all, it's really great being here, and thank you all for attending this session. And I'd also like to thank the organizers for making this possible. It's really great that we have an event around Kubernetes of this size here in Bucharest. Yeah, so I'll present myself. My name is Mihai Gogu. I work at AdoreMe for about 8 years, and for the past 5 years I'm doing exclusively platform work. Before that I worked as a backend engineer, both at AdoreMe and previous companies. So if you're asking yourself what is AdoreMe, so AdoreMe is a lingerie store which basically operates almost entirely online. Very few stores are physical. And I'm not gonna advertise on this presentation. There's no bras in any of my slides. Maybe I disappoint some of you, but yeah. Sorry. Okay, so I'm first gonna introduce you to AdoreMe Scale, so you can have an idea what we use Flux and GitOps for. So we are the tech part is based in Bucharest. We are consisted from core engineering team, which is the platform team that I'm part of, 9 product development teams that we support with platform developer tools and other services, data and BI teams, and we have around 450 Git repositories, which represent microservices, gateways, libraries, you know, Kubernetes manifests, Terraform, and all that we need to operate online. Yeah, our setup consists of 8 GK clusters, so we use Google Cloud. All of them are managed with Flux. We have around 400 and 2,000 Helm releases across our all clusters, and the number varies because of the development environments, which can be raised at any time based on the needs of the teams. So the part with Helm and the heavy usage that we have of Helm, it's actually a decisive factor in us for choosing Flux. At the time when we were searching for a GitOps solution, Flux was the only one that was using the Helm SDK, so we would get all the features that Helm had, which means we had access to hooks, and they were executed as we would expect with the Helm CLI itself. Because we rely on hooks to run migrations, provision things in the dev environments, like creating databases, cleanup, and other things. In terms of the frequency of our deployments, we do around 5,900 deploys in the past year on production alone. If we account for all the other clusters, we go to the tens of thousands. And of course, all of this is done with Flux at AdoreMe. So now I will briefly talk about what is GitOps, so we're all on the same page and we have a basic understanding of it. So when I think of GitOps, I think of 2 main components. So the first one is the way to store your cluster desired state in a declarative way in Git. For us, you can also store it in buckets and in other sources, but we are using Git, and that's what we're gonna use as reference in this talk. And having an automated way of ensuring that the declared state that you keep in your Git repo matches the actual state and the desired state from your clusters. So this can be anything from a script that pulls your Git sources and applies them to the cluster, to a more mature solution like a Kubernetes controller that constantly pulls the data from your source, your GitHub, and applies them to the cluster, assuring that what you think you have in your cluster defined in your Git is actually what you really have in the cluster. So if you're wondering why would you adopt this pattern, we believe there are some advantages. like you end up with a single source of truth, and you kind of eliminate configuration drift, because if you're doing like CI ops, let's say you are using Jenkins, build your app, then run Helm install or kubectl apply from your Jenkins, and then you store the manifests in a repository. Someone can come and do some kubectl edit or other manual interactions with your cluster, and what you have as a backup in your Git repository doesn't match what you end up in your real cluster in terms of days, months, or years. If you go, like long periods, the drift most probably will become very significant. You have out-of-the-box audit logs from Git history, so everyone, at least in our company, has the same workflow. It uses Git to act on clusters, be it the production cluster or dev cluster. So you can protect your main branch that you are syncing to your cluster and have more visibility of what's happening and what's being changed, because you would require pull requests. So someone will see that somebody needs to make a change. Maybe you don't need to make that change. You start a discussion and find other solutions, or someone else will be aware of what's gonna change. It's easier to recover your cluster after a disaster, because what you have in your current cluster before the disaster happens is exactly what you have in Git, and you have the certainty that when you reapply those manifests in your cluster, they will work, because they were the exact same version that it was 1 minute ago. We managed to improve the developer experience and give them that self-service that everybody talks about, because they now have an easy tool for them to understand to manage their apps. So they are using an interface that they know. It's GitHub for us. They know how to make a pull request. They will change their desired state in that pull request. They can increase their, resources, update the scaling of their app, and everything else. So we encourage them to do this themselves and take ownership of their app. They built it, they run it. We don't even require strict approval from us if they want to change their applications, and they can do this in a safe way. They don't need to have access to the cluster with Helm, kubectl, or other tools and run commands that they're not comfortable with. We also had another nice thing, because now both us from the platform team and the rest of the developer teams have the same workflow of interacting with the cluster, which is through pull request in a Git repo. And you also can end up with a secure cluster. This depends on your other setups and other factors, but for the continuous delivery part, you won't need to expose your Kubernetes cluster to other tools like Jenkins or GitHub Actions or any other runner. Because Flux is deployed inside of your cluster, he will pull the manifest from Git and apply them from inside the cluster. So you don't need to do kubectl apply from external sources anymore, or Helm install from external sources. Now, there are several Flux components. I'll go briefly through them. There's the source controller that is responsible with artifact source definition, like Git repo, Helm repos, buckets, and other things. The customize controller that gets these manifests from the source, and it will do validations, it will generate manifests, it will handle the Kubernetes API apply and everything else. Then there's Helm controller, which you obviously will only deploy if you use Helm. If you're not using Helm, you don't need to deploy it. Flux is very flexible in that aspect. It doesn't require you to install all the controllers. Notification controller, same thing. It handles inbound events like webhooks from GitHub or I don't know, your image registry, and outbound events like messages to your Slack channel or other sources. And there's the image automation controllers, which we heavily rely on. So this, the image automation controller, what they do is you can configure to constantly scan your image registry for new versions of your images, and it can automatically deploy your new app versions when a new version is detected. And you can set up different policies if you use Semver, or even if you have some custom mode of tagging your apps, you can configure Flux. Okay, so here we have a typical workflow that we use in AdoreMe for managing and deploying our apps. So when you need to change something to your app, there's this manual flow. You will open a pull request in your Kubernetes manifest repository. Someone will review it, and after you merge it, Flux will be notified by GitHub through a webhook, and it will automatically pull your sources from your repo, and it will start applying the changes that you've made. So this workflow is typically used by teams when they need to change things like resources on their apps, update the scaling, maybe choose another node pool that they want to deploy their workloads and stuff like that. It's not used for releasing new versions of their app. It's for managing their app. So when they have a new version of their app, they will use a typical CI workflow. You know, they would start a new branch from master, open a pull request, GitHub Actions will run the test and checks. They will get a review, and then they will merge the pull request back into master. So how we operate is that every commit to master is a deploy. So that's the way that we are doing all of our app releases. So every developer knows that when he opens a pull request, that will be a deploy automatically when it merges. So they need to take things in consideration that that feature or bug fix needs to work as a standalone. They can't depend on other things, other releases, or something from another repo. That for us triggers another GitHub action, which starts a GitHub action runner that will create the GitHub release, build the app and Docker image, and push the image, in our case in Quay and the Google Artifact Registry, which we are using as a backup, because you should have a backup for your images. Quay might be down sometimes, so you need to be able to switch. And this is where the CI part ends for us. I think this is out of battery. So yeah, when we push the image to Quay, the part with GitHub and CI ends, and the rest is totally decoupled for us. So we don't do kubectl applies or Helm installs from GitHub, from Jenkins, from other part. So here we have Flux inside the cluster that is constantly monitoring both the Kubernetes manifest repository and the Quay repository for changes, for updates. When it detects a new image in Quay, be it on an interval-based scan or triggered by a webhook, it will check if that new image tag matches the policy defined by us. And if it detects that it's a new version, it will deploy that new version for you without you needing to add a single line of code. It's built into Flux. It does it really good. We haven't had any issues with this. So the way that it does that is that it will pull the sources from your Kubernetes repository. Then it will update. In our case, since we are deploying Helm releases, it will update your image tag in your Helm release values and commit it back to the GitHub repository. So either if you're doing a manual update or through an image update automation, the actual deploy has the same path. Commit into Git and then sync it back to your cluster. So it's a nice thing to have two options of deploying and managing your apps, but you have the certainty that both will follow the same path, and it's easier to debug, and it's easier to have an idea of what is happening in your cluster. Okay, so now let's talk a bit about the pros and cons. So we consider the pros to be everything that we've talked up until now. But the cons are maybe things that you should take into consideration when you start the journey with Flux. So I think that, like with any other app, especially in Kubernetes, you need to be aware that you're going to throw another set of CRDs in your clusters that you will need to manage, operate, update, and that comes with that comes with a learning curve, and you shouldn't think, oh, okay, I'll put Flux in my cluster, it will sync everything, and everything is gonna be good, because when it works, it's really great, but things can go wrong, and you should do your research before throwing it into production. But here the Flux community is really helpful. You can go in the Flux channel in the CNCF Slack, and they are really responsive, and they are offering help with all your issues. So that's a good thing to have the support you need when you need it. And another thing is that Flux is really flexible. It's not, I didn't find it in any way opinionated on how you manage your repository and structure it. So that can be also a good thing, but it also can go wrong, because you need to think about a little of how you're structuring your repo, how you're separating your infrastructure from your apps, and even your apps. Because we did something bad when we first started. So we used one customization for our whole cluster, and when something goes wrong, that will block your whole cluster synchronization, and you're blocking other teams from releasing their apps. You end up in unpleasant states, and you should take a look at the examples that they have. They have some great example repos on how you can structure your application and how you can structure your repository and split them by infrastructure that you need, applications, and all that. So what I want to do next is actually show you one of our setups. We have a single repo that is used to manage both the user acceptance testing and the production environments. We tried to make it as less duplicate that we could, and we used Flux to have it sync automatically the clusters without us needing to write a single line of code. Okay, so I need to make this bigger. Okay, so this I think is like a typical repository in Flux. You have the clusters, where you can define a single cluster or as many clusters as you want. So what these contain, like the production cluster, it has the Flux system directory, which is the manifest generated by Flux when you run Flux Bootstrap, and that will contain all the CRDs and the definition for the controllers that will be deployed in your cluster. After that, you need to define a path for this Flux instance to manage and sync into your cluster. So over here, we define that, okay, so for this production cluster, I want you to sync for me this path. And we will go and see what that path contains. Okay, so yeah, the same thing is for user acceptance testing. It has the same things. It has the Flux manifest that will be deployed on a different instance of Kubernetes cluster, and the same. I am telling it, okay, you need to sync the applications that you find in the environment's user acceptance testing. Okay. Okay, so in the applications, we have a base of the apps. Okay, in the base applications, we have defined all the applications in these clusters, and they come with a lot of boilerplate that is usually common between both or many instances of your cluster. So what that really looks like, so we have defined the alerts from these are custom resources from Flux. You can define alerts, send me a Slack message when something happens with my application and there's an error, send me an info alert when the new deploy happens, and all that. Then you would define your image. So this one you will only define if you wish to use the image automation, because this is how Flux knows where to look for new versions of your applications when you push new tags to the registry. You will have the receivers. Over here we have the query receiver, which exposes an endpoint for query to ping when it gets new images. So we won't wait for the interval for Flux to scan new images. Secrets, which I can actually show you because they're not actual secrets. We're using external secret operators, and we pull the data from the Google Secret Manager. And the Helm release, that it's also a Flux custom resource. You can define the chat that you want to use, the version that you have to use. So this is a chart that we maintain internally. We have several charts that we maintain for PHP, Go, Node.js, Python, and other languages. But we also use a lot of the community charts. Okay. And for your actual environments, so you don't want to expose all of this to your developers, because there's a lot of YAML, there's a lot of things that they would need to understand and occupy their minds with. So this is pre-provisioned by us as part of a working app in our Flux ecosystem. They will usually interact with the overlays in the environments, which are much simpler to interact with. So if we go in the same application in the overlay of the production environment, we would only have the release with just a few values that we want to change from the base, because we need to have different values here from between production and UAT. Like we need different replica size, maybe different tags, a different internal ingress, and things like that. So I believe this is pretty easy thing to work with for developers. And you would also define your image policy, another Flux custom resource, and you can say it, okay, from this pattern, extract the semver and deploy every new tag that you find in this range. So it's from 0 to version 1. And it will be the same thing in the UAT environment, just with other values. And all this is managed by Flux, so it knows to get to these paths, run the customize rendering and applying the overlays, and it will automatically sync to whatever cluster you want, all of these changes, and we can manage these two environments in close sync, again, without a single line of code from our part when we talk about the continuous delivery system. And image automation is I find it to be a great tool, because we don't only we're not only using it for production to deploy new versions to productions. We are also using it in our dev environment, where we have anywhere from 30 to 40 different testing environments. So people would deploy anything from a couple of microservices to the whole site there. You are gonna work probably on a single or two microservices, but the rest you would like to be synced with the master. So what we do, we use image automation to constantly sync in all these tens of environments the latest version for that app from production. So when a new version gets into production for, let's say, the customer microservice, all 30 or 40 environments in dev react and are updated by Flux with that specific new version. So it's, again, it's a great tool. We didn't have to do almost any work to obtain this degree of reliability and the continuous delivery that we wanted. So that being said, I think we have some time for questions. If you have any questions, I'd like to thank you for attending this session, and I hope you got something useful out of it. Thank you.
Okay, so questions? Someone?
Thank you for the presentation. Could you please tell what is your process of delivering hotfixes to production in terms of CI/CD?
Yeah, I'll just go back to this one. So when we're talking about features or changes to production, our process is you would start a pull request, start a new branch from your master branch in your application. You would open a pull request. We have GitHub Actions to run all the tests that we need and checks and validations. You would get an approval from your peers, and then you would merge that branch back into master. And that will trigger a new GitHub Action build that will build your image, push it to Quay, and this is the end of the part of the CI. Then Flux, Then Flux will detect that you pushed a new image to Quay. It will check if it's a valid version for it to deploy, and it will automatically deploy it for you by committing the new version in the Kubernetes manifest repository. I don't know if I answered you, or do you need more?
I mean, if you would like to deliver hotfix to production, where do you test it? Do you deploy a new environment for testing it?
No, people test it in a dev environment. After that, it will pass through all the checks and tests that we have in our CI, and then it will go to production. For our production, I gave you an example with the user acceptance testing. In our production, we are constantly delivering it to production after it passes the checks in the dev environment and the checks from the CI.
But the environment could have changes which we don't want to check and don't want to have on production.
I didn't get that. Can you speak
I mean,
louder?
like it's far away ahead from production dev environment, and you would like to deliver a hotfix to production. I mean, like you deployed version 1 in production, and you would like to make a hotfix to version 1, but on dev environment you have version 2, and all other services are on version 2.
We have different dev environments. You can deploy a dev environment with whatever version you want to test it.
Okay, got it. Thank you.
Yeah.
I think we can take one more question.
Hi there, and thanks for the presentation. I was wondering, you mentioned at the beginning having to choose between Flux CD and others. I presume one of the obvious other choices was Flux. It was
Argo.
Argo, of course. And I was curious, what made you mentioned the fact that this one uses the Helm API, and this gave you access to much more features.
Yeah.
But maybe there were other considerations as well. For instance, we're using the GitLab pipelines. We're not using neither Flux nor Argo. And I was curious, because I was looking into this one as well, and I was curious what made you decide versus Flux against Argo, because both seem popular to some people, one to some other people, others.
Yeah, well, that was the main reason, the fact that we could deploy what we already had in place with Helm, because we were using Helm before Flux, so we didn't want to change all that and lose all the hooks that we developed. And also we find it like it was a nicer experience to start. And it just offered what it says, if you go to their website, it's Flux CD, so it only offers the CD part. It was simpler to understand. The components were really modular. You could install whatever, just what you needed. And it was easier for us to start with it. So, it promises CD, that's the only thing that offers, and it was a smooth ride for us with it.
So, thank you for your presentation. I was wondering, why did you choose to use Flux for your dev environment as well? Because I think, in my opinion, that would maybe pollute your Git repo with a lot of commits that are like redundant, and generally speaking, the dev environments are way more volatile, let's say. They change way more often than the production one. And I think maybe, why didn't you consider other solutions that are dedicated for this? For example, like, I don't know, Octeto or DevPod or something like that?
We had other setup at first, so we were doing directly Helm installs from Jenkins. But the fact that we could sync this many environments without us actually have to develop internally tools was a big plus, and it started as an experiment. Maybe it will change in the future. We're experimenting with other things also. But it started as an experiment. It went well, and we just appreciate the advantages that it offers. But you have a point, because you have a lot more friction and yet another layer in the dev environments that are more volatile. But yeah, we're searching for other solutions if they will work better for us. But right now we're pretty happy with this also.
Okay, thanks Mihai.
Thank
Thanks
you.
everyone.
Thank you.